I take a spring and I put a little weight on it, and then I shift it slightly from its balance. What would happen would be that the spring would start oscillating. Why is it like so, and how do we describe it mathematically? Well, for this we will need the differential equations that we spoke of earlier. This is the best example for application of differential equations in basic physics. So actually we use Newton's second law. So on the one hand we have m times a, which is actually the second derivative of x. So we have m times the second derivative of x. And on the other side of the equation we have f. What is f? F is the force of the spring that we spoke of in an earlier video. So the force of the spring is proportional to k times x. So we have this differential equation that looks something like m times the second derivative of x is equal to k times x. In other words, we have that x is equal to its second derivative times some kind of constant. And what equation is the same when I perform a derivative upon it twice, except for a constant? Well, there are several answers to this question, but the simple one would be a sine function. If you perform the derivative on a sine, you get a cosine, and if you perform the derivative on a cosine, you get a minus sine. So if you perform a derivative twice on a sine, you get a minus sine, and if you perform the derivative twice on a cosine, you get a minus cosine. In other words, you get the same function twice, only with a difference of plus or minus. This is why the position of this oscillating spring can be described via a sine or a cosine function. And this is the solution to the differential equation.